cafe ring. Ooh. Can you see me? Veronica. Ooh.
What's the number one?
What number are you on?
We're up there. And we played the game. Yesterday we did the race. Look, we're not from the parking lot, we're into the front parking lot, we're not from that. Ran all the way back around to the senior parking lot, one more around that. Did that twice. And then the other one.
That's how I was like,
The calls of the baseball.
it was Saturday, and I was like, okay, it's like, so it's not already started.
Down. Nah. You don't get it because the baseball field is down, so it's all swampy. Like it's foul line, all the balls, you know? So he made it from that like 8 times.
Well, it's probably gonna
Because
be
of all of us. Everybody else knows that. Oh.
Oh no, one time, I forgot, I didn't, Bible. I was just she was gonna give you, like, grade on.
Yeah.
It's not hard, it's just.
Once I know what happens.
I do too, I just sit up, I just look at it and I'm like, I look at it, I look at it, I'm like, I'll do that tomorrow.
Hey, I was the first person done.
It's hard to do that.
That's a time all the way. I was really.
I forget what you did that. One day, everybody was like 3 times that high.
What? Sean Joseph and he's fun. He'll start showing off. That's when he can throw it. He'll do like flips and then throw it in.
That's when to be like, yo, you taking this work.
Jagger starts. He's like the him and Taylor are the only freshmen now. I mean, he's left with this for sure. That's probably the only reason he starts. That's not necessarily bad, it's like, you know, you'd rather have somebody who's on the left than someone.
Yeah. I was more about funny.
Didn't say fourth he's so fucking fun. I mean, he's probably better than me. He just kind of like,
Wherever.
yeah, I usually.
Yeah. I don't know how you
I want to see you run a 40-yard dash one day. Hey, we'll see. All right. Morning. Morning. How are you?
Mr. Kaufman, do you want us to sit at our desk? Yes?
How's that phone coming along, Brett?
A what? I completely forgot about that.
Do you want us to sit at our desk? Sit at our desk.
That's up to you, man. You can turn if you want. Some people didn't turn yesterday, so it's up to you. I mean, I get it if you don't want to look at Parker the whole time, that's fine. I wonder if that's the one you want to talk about next year. No, you talk about it.
Yeah.
But I'm like, well, I'm done anything.
She's not even around that point. She's kind of. I'm sorry. What are the pictures there from? Your time? I'm thinking about it. I was teaching over there about my board. It's like right by my board. What?
Well, I'm here to do it, so I'll do it next year. So, I'll remind you.
Give me a refresher.
Yeah. You don't need to forward you the stuff that was sent to me? Well, tell you what, I'll do that right now.
Okay.
I'm gonna go for 20 years.
But you're asking me.
Sure.
It's like, I think so. I would say grade level, so.
It's some of the time you use it.
Like this.
No, that's not one. You can still try to plug it if you want. I don't think it'll work.
Is that Bluetooth?
This is a paper copy of this thing, right? This one. Okay, guys. 2 more problems here today. One taking us through basically what we talked about yesterday. Very similar to that number 15 from the homework we did. A lot of us did very well. I'm still working on grading our quizzes, but most of us do pretty well here with this question, so I just want to make sure we're still doing okay with this. And down here, little optimization problem for us. Todd? That is x squared minus 9 for my denominator. X squared minus 9 here. I'll try to rewrite this a little bit bigger here. Domino Loop today. Unless everybody's seen Domino Loop today? Oh, yeah, that's right, he said he was gonna be.
This guy would pay attention. You know that.
Pardon?
Help us do this after arms. Help us do this after arms.
Well, so our 3.9 homework for me to collect, right? Well, I'm not gonna collect, because you know what I mean. Okay, good work, Jay, good work. Give us another minute or two to, work on our warm-up problems here. Answer key for the 3.9 homework for anybody that wants to see it. Answer key for 3.9 homework. Sure.
Number one's 122.
Yeah, there's probably the typo. If I missed Kaufman, I mean Miss Mazaka, probably just miswrote. Or it's probably my fault. It's probably my fault. Wise man should not blame his wife, especially when she helps him out. Need me to scroll down there for the answer key? Ready to scroll down? It's like, oh,
Says, I'm not sure. That was wrong. That's the number.
let's keep it answering. So keep going, one step. All right, let's go ahead, let's get ourselves rolling here a little bit. Do we have any questions on 3.9? Let's start with that. Any questions here on 3.9? Any issues, anything we'd like to talk about with last night's homework? John? Number 6. Gotta find a copy of last night's homework, so that way I know what number 6 is. Any other questions other than number 6 for our 3.9 homework we'd like to talk about? Take a look at 6's answer right there. This is study guide. Okay. So let's just pull up the homework here. Back up. Okay, number 6. We want to find an equation of the tangent line that can be employed to approximate the value of this x squared plus 8, where x is going to be equal to a here. So we're actually going to plug in a different value here. So of course, what do we need to do first to start this question? What do we need to do first to work number 6 here? First steps. Go ahead, Adam. We're going to find the derivative, right? And our equation there is, again, it's square root of x squared plus 8, correct? So we have here, so let's find the derivative here. Now this is going to be a pretty straightforward chain rule application. We're going to go ahead and rewrite this just so that way it's to the 1/2 as we like, right? So when we're looking at our first derivative here, or dy dx, we're taking, of course, the derivative of the outside, which is going to give us a 1/2, and our x squared plus 8 to the negative 1/2, yes? And then, of course, times derivative of what's inside, which will be 2x. And we're going to go ahead and simplify this 2 and this half are going to cancel. I'm going to get x on the top of my fraction alone. And on the bottom, I'm going to have my square root x squared plus 8. And this is my dy dx here. Are we okay so far with our first derivative for this? Are we all comfortable here? Okay, now let's be clear. Let's be clear here. We want the equation of the tangent line that can be employed. What would this give us right now? What will this give us? This is going to give us slope at A, right? So if I swap this over, this is just going to be, I'm going to use capital A's because we all know my lowercase a's don't look very good. We're going to have A over A squared plus 8. This would be our slope here for our tangent line, yes? Okay, so if we're going to set up our tangent line, y minus y1 and x minus x1, correct? Well, we have this right here. We have this is going to be A, correct? And we just found slope. That's, of course, A over square root A squared plus 8. And what we need here is we'll need y1, which would be when I plug A back into the original, correct? Which would be y minus square root A squared plus 8. Questions here thus far about what we're doing, where we're going, how we're feeling? Okay, let's just double check back over here with our keys real quick. Okay, so this is where I began. This is the information we've collected. So right here, of course, on the right side, I had found f of A, or my y1 that I just did, right? I have here the derivative to give me my slope, the A over A squared plus 8, and so forward to right here, correct? So from this point, it's just some algebra work, where we're going to get this all equal on one side. Just some algebra work to get everything to one side. I think the best course of action here is to go ahead and distribute. And this will become ax minus a squared all over square root a squared plus 8. Then I'll send my other root to the other side. So I have ax minus a squared over square root a squared plus 8 plus square root a squared plus 8. I can bring that in by making it into a common denominator, which is going to give us ax minus a squared. This is going to become plus a squared plus 8 all over square root a squared plus 8. The a squared will cancel. I'm looking at ax minus 8 square root a squared plus 8. Are we okay with what my work is and how we got to our answer here? Other questions from 3.9 that we'd like to look at? Any other concerns? Parker?
I don't see a squared minus a over the square root of a squared plus a on the answers, because it's multiple choice. I don't see that one of the answers.
Is that not one of my answers?
I put B because I thought that's what I got.
Do I have a typo on my sheet here? Parker, it is B right here. Right above it.
Yeah, that's a squared, ax plus a though.
Yeah, that's what I have.
Ax minus a.
Oh. How did I get plus A? How did I get plus A? Let's double check my work here. Maybe Mr. Kaufman just has a typo on his sheet. Maybe I did something wrong. Let's double check. Okay, so let's double check our derivative. Derivative looks good, right? Okay. And we'll just slam A in. Okay. That one's good. We distribute, we're going to get ax minus a squared. Yes. We're going to add that over. Yep. Yep. I'm not sure where I got the minus from. Not sure where I got the minus from. Might just be a typo. Might just be a typo.
You didn't take away the minus because you canceled out a negative a squared and a positive a squared. You just never took away the minus.
Yep, that's probably what it is. There it is. Thank you, Emery. You guys are so smart. Oh, it's figuring out what Mr. Kaufman's doing wrong. All right, other questions we want to talk about? 3.9 homework. Okay. Let's turn our attention then to our warm-up problems. Turn our attention then to our warm-up problems. Who'd like to help us get started here? There's enough work to be done for plenty of us. Who'd like to help us get started? Okay, well, what would you like to do? Where do you want to start? Do you want to start the long, arduous one, or do you want to help me do some optimization?
I'll start the first.
Start the first one, okay? Where are we going to start the first one at then, miss?
First I wrote out my undefined zero.
Okay, so we're going to find our asymptotes, right? Tell me what I'm going to write.
It's undefined as positive or negative.
Okay, so x squared minus 9 equals 0, so that gives us plus minus 3, right? So that gives us two asymptotes, two vertical asymptotes at x plus minus 3, right? Okay, so these are vertical asymptotes, VAs. What else can we do? What about horizontal asymptotes? Let's do that one here too. HA. What are we going to be looking at there? It is not 0. It is not 0. What's the horizontal asymptote here? We're looking at the degrees. The degree on the top and bottom are equal, so we'll look at the coefficients. It's going to be at 2, specifically y equal 2. So we have vertical asymptote at plus minus 3. We got a horizontal asymptote at HA at y equal to positive 2. Are we all okay with this? It's not a lot of work, but it is work that I'll be looking for. Okay, what else do we need to do? Okay, we got to start and somebody else do something. There's easy parts and hard parts still remaining. Parker?
Find the derivative.
Find the derivative, okay, so that'll help us with the increasing, decreasing, and max mins, right? Okay, so let's go ahead, let's find the first derivative. Now this is of course going to be a product or a quotient rule, yes? So we got g squared on the bottom. We got g f derivative minus f g derivative, correct? Normally I would do the derivatives off to the side, but I think we can do these without having to write that out. So let's show x squared minus 9 quantity squared down here, correct? Our first term is going to look like what here?
X squared minus 9, 4x, and then minus 2x squared, and then 2x.
Okay? When we simplify this down a little bit, we should be looking at x squared minus 9 quantity squared, correct? We should be looking at 4x cubed minus 36x, yes? Minus 4x cubed, yes? Let's get this 4x cubed. We have negative 36x over x squared minus 9 quantity squared, correct? This is our first derivative here for this function. Are we all comfortable here? Okay, I do want to go ahead and point out a couple of things here when we talk about points of inflections later on. We want to talk about some things here that we need to talk about with points of inflection a little bit later on. But let's run our full first derivative test. That's what you said, right? So we already know when this does not exist, correct? That's, of course, at our asymptotes plus minus 3, yes? We're also going to have some zeros here. When is that going to occur?
At x equals 0.
At x equals 0. Negative 36 equals 0, and then x equals 0, right? I don't need you to re-show this part because you already should have shown it up here. Because they're vertical asymptotes, therefore they should be a point where the function, where the derivative should not exist. Okay, let's run our test here. 0, negative 3, positive 3. So we're going to have to plug in 1, 2, 3, 4 numbers here, Parker. What do we got so far?
You can plug in -4, and then I'm pretty sure that gives you a negative.
If I plug in -4, it's going to give me a positive.
Oh, positive.
Because what's going to happen, Parker, is I'll have 2 negatives on the top, make that positive, right? This squared will spit out only positive numbers. This squared will spit out only positive numbers. So there's really no way for this denominator to be anything other than positive, right? So we are plus here. What about between -3 and 0? Let's say -1.
That would also be positive.
It's also going to be positive. We'll get a positive 36 here. Yes, we'll get a negative in the parentheses, but then we're squaring it anyway. So we're going to get back to positive over positive again. So still plus. So that means on both sides of the asymptote, we should be increasing. Yes? Okay, what about at 0? Let's swap over to the other side. What about at 1?
That would be negative.
That's going to be negative 36 on the top, and we will get a positive on the bottom. As we talked, it's always going to be positive on the bottom, so negative here. What about something larger than?
Still negative.
Still negative. Absolutely, because we're still going to be negative on the top. We're still going to be positive on the bottom. Now, you can work those out, and that's what I'd like you to do. I'm skipping over that so that way I don't have to erase everything on my board. But I would like to see us have a little bit of work here to back up where our pluses and minuses are going. If you've done a ton of work here, help me fill in some answers here. What do you want to tell me?
The interval of increasing is -infinity to, what is it, 0?
-3, because that's an asymptote. And then -3 through 0. Interval of decreasing would be 0 through 3, and then 3 through infinite. Some of us made that mistake on our quiz. It's part of the reason why I brought this question up here for us. We can't be increasing over the asymptote because the asymptote's not part of the graph. We don't have a value there. Okay? Parker's done a lot of work. I'm going to go ahead and let somebody else pick it up here. Now, they can just continue on what you have because there's a few more answers we could state. Or we could simply move on to something else. Who'd like to pick up here? Allie, what you got for me?
You got a maximum at x equals 0.
We have a maximum at 0 right here. We're going from positive to negative, right? It's not at a asymptote, so that is a max at 0. This is going to be relative or absolute. It is relative. It's going to be relative. You know how I know that? We're coming up, increasing, right? So that means we're coming from negative infinite up, right? And from here, we're going back down. So this could be relative. It could be absolute. We got to think about it maybe a little bit more clearly. Okay? maybe we could use concavity to help us back up whether or not we think it's going to be relative or absolute, okay? You said it like a question. Are you sure it's relative?
No, not really.
No, not really? Okay, then I'll tell you what. I'll erase this off here until we are sure. Okay? Now, of course, we do need to get the y value for this. 0, what? 0, 0 is looking like a maximum here for us. Looking like a maximum here for us. We skipped over a couple of things. But now it's giving us another good point here. Who else wants to pick up here? Who else wants to help us out?
So would you take points off if we didn't put relative or absolute?
We're going to come back to that. We're going to fill in which one it is. So yes, I do expect you to put in whether it's going to be relative max or absolute max. We talked about the differences between them. Make no mistake, the last thing we're going to do here is sketch this graph. And at that point, if it hasn't been clear yet, it should be clear then whether it's a relative or absolute max. Does that answer your question? By the time you finish this problem, one way or another, you should know whether it's relative or absolute. Right?
Find the second derivative.
Find the second derivative. Okay, we're going to keep doing the hard stuff and keep skipping over the easy stuff. All right? I'm all about it. Let's pick up our first derivative right here. We're going to need to set up our second derivative, which is going to be another quotient rule, correct?
Right.
So we're looking at g squared, gf derivative minus f g derivative. We might want to write this one out just a little bit, Ryan, just to be cautious here. Of course, f derivative is easy. That's negative 36. G's derivative is the one that we're going to be looking at a little bit more closely. That should be 2x squared minus 9 times what's inside the parentheses, which is 2x, yes? So I think that g's derivative together is looking like 4x x squared minus 9. Correct?
Yeah, I think so.
Yeah? I think so as well. Let's go ahead. Let's set up our second derivative. On the bottom here, we've got x squared minus 9, quantity squared, or x squared minus 9 to the 4th. We've got g, which is, of course, x squared minus 9, quantity squared, times our f derivative, which is negative 36, minus our f, which is negative 36x, times our g derivative, which is 4x, x squared minus 9. Are we all okay with just the setup here? Okay? Ryan, I do see this x squared minus 9 everywhere, so let's take at least one of them out. Agreed?
Yeah.
Okay? So I'm looking at x squared minus 9 to the 3rd here on the bottom. I got x squared minus 9 and negative 36. That's just to the single power. And that gets rid of this one together. So that just gives us what's end up going to be positive. And then 4 times 36 is 120, 144. X squared.
One thing I've never understood whenever you do one of these problems is how do you get rid of 2 of the x squared minus 9? Because you get one on the right side.
I'm getting rid of one on the right side, one on the left side, and one underneath. I'm factoring out x squared minus 9 from both groups here, and then canceling it with the one below.
I thought you were just canceling them out from the denominator instead of factoring.
Yeah, that's factor them out and then cancel with the denominator is what I'm doing. I'm just not showing those steps. But a good question, Mark. Ready to keep going, Ryan?
Yeah.
Okay, what we got so far?
For the derivative, we can have negative 36x squared plus 9 times 36. It'd be times, or no, plus 324.
324. And then plus our 144 x squared, correct?
Yeah.
Okay, let's put our x squared together.
be 108 x squared.
108 x squared. Are we all okay so far? Now, Ryan, it might help some others here. If instead of reading this as 108 and 324, both of those are in fact divisible by 9. Both of them are actually divisible by even larger than 9. Both are actually, it should be divisible by, double check here real quick, make sure my math is right. But both of them are actually divisible by 9 and 8. So, that means both divisible by the product of them, which is 108. So the best simplified way to write this is 108 x squared plus 3 over x squared minus 9. Questions here? Sure are choosing the hard way to do this problem. I guess you shouldn't say the hard way, it's just that we're still skipping over easy parts. Ryan did a lot of great work, real proud of that work, Ryan, I like it a lot. What else we got going on here? You want to pick up where Ryan's leaving off? Todd, why don't you weigh in? What you got for me? I have second derivative, so I can do concavity and points of inflection. And we still haven't done the intercepts yet, so. Okay, so just going to continue on with that. So take that equal to 0. 108 x squared plus 3. Does it ever equal 0? The bottom part will, right? That's going to give us a point that does not exist. But will the function ever actually reach 0? Is 0 a reachable goal for us? I don't think it is. For us to get to 0, this x squared plus 3 has to go to 0, right? Okay, x squared plus 3 can't be 0. So I don't think there's any 0 points here for us. I do think that there is a does not exist value. And of course, that's where you just set at the same as the vertical asymptotes, the plus minus 3s. Questions here? Concerns here? My number line, -3, +3. Okay, let's plug it in. If I plug in, let's say -4, what's going to happen? I'm going to get a positive on top and a positive on the bottom. We will get, if I said we put in -4, we'll get 16 minus 9 here, which will give us a positive number, right? Okay, so we are plus there. What about in between the two? Let's say if we put in 0, what's going to happen? Very good, so negative overall, right? Okay, and then anything on the other side of 3 is going to also be positive. So we have concave up and concave down here, right? So we are concave up. And we are concave down between the 3 values. This should tell us whether this is an absolute max or min now for 0. This should tell us what this is now. But if we're still not sure, we can wait till we sketch the graph. Todd says it's relative. So we'll put relative for now. That's what Allie said earlier, but she wasn't 100% sure. So we'll put relative, and then we'll draw the picture. We'll back it up. Because, you're not done until I grade it. So if you get conflicting information at some point, you can always change your answer. You're not set in stone, right? Okay. 2 more things to do here. Well, technically 3. X-intercept, Y-intercept, and inflection points. Who wants to help us? Caleb, what you want to do?
I got the X and Y intercepts.
Okay? X and Y intercepts. That's easy. How do we find the X-intercept?
Plug in 0 for X.
Well, not for the X-intercept. We plug in 0 for the Y for the X-intercept. If I plug in 0 for X, that's going to find the Y-intercept.
Oh, yeah.
Okay? So that'd be 2, 0. That's, of course, going to happen at where, sir?
0.
At 0. So I have Y-intercept at 0, 0, right? Okay? Isn't that going to be the same thing for my other one, right? If I set 0 and then 2x squared over x squared minus 9, that's eventually going to become 2x squared equal to 0, which is, of course, x equals 0. So the intercept here is actually the same, which, lo and behold, is the same maximum we're talking about here, too, isn't it? Okay. That part's done. I probably would do that alongside when I do the asymptotes, but that's just me, because all 4 of those are real quick and easy things for me to knock out. But you do them in whatever order you want, I guess. Nope, just a ghost. This conference room is haunted. All right. 2 more things left to do, the inflection points, and then we'll draw a graph. John or Dawson? This is the point that we're at now. Everybody else is gone other than you 2. Who's weighing in? John, inflection points.
I say -3 and 3.
I say you're wrong. Those aren't points. Those are asymptotes. For it to be an inflection point of the graph, it has to be a point in the graph. There are no inflection points here. There are none. This is a mistake several of us made on our most recent quiz. That's why I wanted to do this one here for a number of reasons. We talked about a couple of things we had some issues with. There are no inflection points. Now, some people would argue with me. Don't get me wrong. This is not something that everybody agrees about in calculus. But for me, for it to be an inflection point of the graph, it has to be actually a point in the graph. And this is not. At 3, we don't have a graph. We have an asymptote. So to me, that's not an inflection point. To many others, it wouldn't be an inflection point. But there are some who would argue that it is. But our curriculum states clearly that it's not, because it's not part of the graph. Okay? Now, Dawson, last but most certainly not least, let's draw a picture, man. Let's draw a picture. I'm going to erase all my work here in the middle with my second derivative so we have somewhere to put it, okay? All right, Dawson, we can fill in some information here, right? We got asymptotes here, right? And here, right? We got 0, 0 as a point, right? Okay, now we need to rely on our increasing, decreasing, and our concavities here to help us, okay? We do. Where is that at? At 2. So, Dawson, let's work left to right. So from left side coming in, we should be increasing, right? Negative infinite to negative 3. So we are going to curve up, right? Or we are going to be coming up, I should say, not curve up. I say curve up because we are also concave up there, correct? So for us, it's looking like this right here, correct? It can't be down here because then the asymptotes would curve it into a concave down position. Are we all clear? Okay? Doesn't this immediately rule out that this is an absolute maximum then, by the way? Because now this is shooting up forever. Okay, so Todd and Allie were both right. You got to be more confident about it. Okay? Dawson, next part here. Between the threes, we have increasing and decreasing, right? So we're going to come up and come down, right? And we are concave down here, so that's going to give us our max. So it's going to look almost parabolic, but not quite, because it's shortened up. Parabolas continue outward. This is just going to go straight down pretty much at a point. And then over here, it looks like we're going to be something like this, concave up, right? But now we are decreasing, so starting high and coming lower. This is my sketch. So even if you can't figure out these tests to tell you whether it's absolute or relative, by the time you draw this picture, you should, unless you got something else wrong along the way. By the time we get to here, we should be able to clearly see that this is a relative maximum. Questions? Issues? I like these problems, man. Fill the whole board with work. Count them for like 20 points apiece. That's not an overestimation, by the way. I think I'm counting this one as like at least 10 or 12 points. Probably more like 15 on your test. Okay, we've all gone, which was the plan. Who wants to help us? Round 2, maximize, minimize, do some optimization here. We got a box with a square base. We got a volume with a surface area. What do we need here? Let's get some basics going. Come on. Kids on live stream want to go back to sleep. I can't go back to sleep until we get done with our warm-up problems. Todd, what we got? Okay, volume here is going to be x squared times y, because you don't know that the box here is perfectly cubed. I didn't tell you it's a cube, I just said we have a box, right? So we know that we have a square base, so that's our x squared. Y representing our height, right? Okay, that looks good. Let's swap this out, V for our 256, agreed? Because that's the volume that we have here for cubic inches, yes? Okay, now what? Let's start with the surface area formula. What's the general surface area formula for this shape, for a box? No, I'm talking like height, length, width. What's our general surface area here for a prism? Okay, so you all got Chromebooks, you all got phones. The Oracle knows all if you're not 100% sure. Type in surface area of a prism. Yes, sir, that's what I'm looking for to start with. Do you have it? Okay, well then let's look it up. Give it a quick Google. I don't know why Todd's the one reaching for his Chromebook right now. If you don't know it, you gotta look it up too. Surface area of a rectangular prism. There it is. That's the formula. That's the formula. Right there in Google. So, we have 2 length plus height, length plus height, width. Okay? Now, Todd, this might be worthwhile writing out over here at some point. Height is y, as we've defined it, right? And the other two, width and length, are going to be our x's, yes? Okay? Now, how do you want to do this right now? Do you want to get rid of x's or y's? Or do you want to wait, see how everything plugs in, and then go from there? Okay, let's do that then. Surface area 2, this will be x and x again, right? Plus yx plus yx, right? So Todd, when I look at this, when I combine everything out here, I'm looking at 2. I got x squared plus 2yx. Okay? What do you want to get rid of, x's or y's? Y's, okay? So let's solve this over here for y. That's going to make this 256 divided by x squared, correct? Okay, so let's bring that in. I'll switch over to a different color here. Let's go to black now. The surface area is 2. We'll send that 2 through in a minute. X squared plus 256 x all over x squared. Let's do a little simplify here. Let's get rid of this x on the top. Surface area 2x squared plus 4 times 256 over x. Are we all okay with what I've done? Todd, good so far? Okay. What's 4 times 256, Todd? 1024. Are we all okay with what Todd and I have done? Okay. I'm letting Todd off the hook because he stepped up to do the problem for at least part of it. He's going to take it over. 5, 4, 3, 2, 1. Todd, pick someone. Pardon? Jonathan. Jonathan, you and I are going to finish it out. What are we going to do with this equation that Todd has lovingly, painstakingly made for us?
I'm not sure.
What do I want? I want minimums or maximums, right? How do I find those?
By equaling to 0.
Pardon?
Equaling to 0.
No, not yet. Maybe if you ask your friend Allie, she'll help you.
Good thing. Oh, find the derivative.
Find the derivative. Okay? Derivative of this should be relatively easy. Derivative of the surface area for x. It's going to be 4x, correct? When that 2 comes down. And it's going to be minus 1024 x to the negative second now, right? Or if we want to send that back underneath, x squared. Okay, what are we looking for out of this thing? What are we going to look for out of this thing? What are we going to do with our derivative here?
Not to be equal to 0.
Equal to 0 or does not exist, right? Those are the two things we're going to be concerned about. It does not exist.
0.
At 0, okay, now is 0 a reasonable answer for this? We're talking heights and widths and lengths here. We can't have a width and length of 0, right? That doesn't make any sense. So let's set it equal to 0, and let's not focus on the does not exist fact. So, 0, 4x minus 1024 over x squared. Let's send that to the other side. Let's make it positive. Let's start with that, right? Okay? 1024 x squared 4x. Let's get that x squared out the bottom. Agreed? I got 1024 4x cubed now. Let's divide that 4 out. We're going to get back to 256. Equal to x cubed, right? Let's take the cube root. What do we got? Is 256 the perfect cube, sir?
No.
Nope. Okay, so what perfect cube goes into 256? I think it's 64 works. 64 is perfect cube. 64 is 4. And then we got the cube root of 4. For x. Length we're talking about. Now that we have it, we can put it back in, get our surface area. Right? Well, first we'd have to find y. Well, I guess we could do it right here if we wanted. Questions here? Concerns here? Tom just keeps dropping everything today. Okay, that took longer than I thought it was going to. More participation would have made it go a little faster instead of having to pull some teeth. But nonetheless, I'm going to let our kids on the live stream go because what we're going to do now is work on our study guide. That's what we're going to do from this point forward. That's what I passed out to you all when you walked in. So, unless we have questions, that's what we're going to work with. No, because I didn't plug it back in. If I want to plug it back in, Todd, I can either plug it back in at this step, that's for x's alone, or I guess not really that step, I guess I'd go right here, because that one's a little bit easier. Or if you do want to go back and get y, then you could go back to here, do that as well. It does need to go back into the surface area formula though, because that's what I asked this for. Not what dimensions create the minimal surface area, but.
So whenever you plug x and y back into the surface area formula, is that your answer?
That would be the answer here,
Okay.
yes. So that's where it comes back into, at that point, answering the question, right? We have the things that we need to actually do it now. If we go back to those notes, right? To what we talked about on 3.7. The last step here was answer the question. So at this point, we've done all the calculus we need. Now let's just go back and do the little bits of algebra that still remain. Okay? Questions? Good questions, though. All right, then. Let's get to work on our study guide.